Okay. I understood some parts of what Janne said. My Estonian, as you know who know me, is not very fluent, so I will take everything in English. The agenda, what I'm going to talk about, is that we have a course now has started that is called Small Craft Construction, and I will talk a little bit about what's behind that course from the beginning, what is from that, and the background, and also some of the parts that it's implemented in that one, so you will get the knowledge about what it is and then what is should be provided and how it works. If you have questions during this one, so please interrupt at once. A little bit about myself then. I'm a naval architect from Sweden, Royal Institute of Electrical Technology. I have mainly worked at Defense Material Administration in Sweden, which is the one that provides all the material for the Navy forces, armed forces, and JAS Gripen, for example. Now I'm the owner at Poseidon Consults, which is then mainly into product management of boats and ships, design office, and also visualizations, but with an additional part of public procurement. The vessels which I've mainly worked with is from Defense Material Administration, small corvettes, 50 meters, mid-life upgrades with combat system, engine system, machinery systems, weapons and stuff like that, stealth design, and also then for the Coast Guard vessels, to the left you have multi-purpose vessels, a oil recovery vessel now built in Peene Shipwerft in Germany. Should have been going to sea trials here for a couple of weeks ago. And then on the right we have the one main focus right now, KBV 312, which is a patrol vessel now built by Baltic Workboats. In all these one, everything starts usually with there is something that would like to have something. Now I do it like this so I easily can keep track before the next one. And we mainly have two different types of procurements. We have the public procurement when a governmental gets out and tries to start to buy a vessel. It is very much differently from a private procurement in terms of in a public procurement, when you go out, you need to have a certain specified specification which should be fulfilled, which on the other hand makes it easy to see what you should fulfill. There's also budget work that is set the cost. I will talk a little bit about that more earlier. If you have a private customer, which perhaps only some of the users have large yards with private customers, they normally scan the market to see what they can get for a good price, as you do, as always, if you're going to buy a car or whatever. And they have soft requirements. And that is not necessarily better to have soft requirements than these hard specification, because it is very often that these soft requirements is twisted, that they want to have a little bit more all the time. So it's not a certain amount of things that is actually specified what to do. And it might be that it also never ends what to do. In this particular course, to make it a little bit easier, we have main focused on the public procurement stuff. So we have a specification based on the real specification that was sent out for a year ago probably from a government for real vessel, which now is a little bit twisted to fit it against these cores. We'll come back to that one. Mainly the budget work in public procurement starts in extreme long time in advance. About for a vessel of this one, 312, it actually started 2006 to start it to be set up the approximately value what are going then to be purchased 2010. And usually that is not any taken care of the market going up and down, which have a huge impact of the price. It is often checked from the vessels you already have, that you check that to see what a similar vessel would cost today, but that vessel of course then is 20 years, so you're going to change it, and what a similar vessel would cost, so you don't take into account that there's a certain amount of living standard that have been improved. There might not be 12 persons in one cabin. It might be that it's only single cabins allowed. It doesn't take into account the development of regulations. Earlier you had easier regulations for noise. Now they are pretty hard, especially for small vessels. They are extreme hard if you should follow the regulations what is. It's also then based on the price for a platform, what they had on that amount today, for then 3 years in advance or 4 years in advance, and they doesn't take into account the project administrative cost. And normally when you have a governmental that buys stuff, there's pretty much a lot of people involved, and also the specification is based on what you thought you knew then would be the right one, but then you had add-ons that need to be add-on to get the vessel what you have after order. So in general it's about 25% of the budget needs to be left over after you actually have done the procurement of the vessel, to be able to have the people, administrative, to have be able to have all the add-ons that we're going to be collected and stuff like that. This mainly make it as it is, that the budget is actually up in the clouds in general from the beginning. And all these budgets from governmental, normally they have this fixed price already set then. 3 years, 4 years in advance, there is a fixed price that is, this is how much it's going to take. And for that, you're going to make a vessel of later on. And when the specification part starts to write the specification, it normally starts that you have an overall document, like an operational tactical document. In the Navy systems you have a little bit more advanced when you include weapon systems and how they should control them. But they only set the basic requirement for speed, tactical range, etc., etc. And then you had the add-on from all the users, which then adds a lot of things that is needed, like rib boats and stuff like that. But then it also comes in all these nice to have requirements. That it's good to have a sink in each cabin, separate toilet of course for each crew member, etc., etc. Then in order to know that you are somewhat within the level, a budget quotation is sent out to a couple of yards. I don't know if you have anyone have a yard here that have received something like that. You are asked to fill in a certain form. You get a small description of the vessel, and then you get to say about what price it would cost to build it, to see if the governmental is in the limit. Often if you send out for 10, you get 6 answers back, and 1 is in budget and the 5 is probably not the rest of it. But then it's usually also, and this is very hard to prevent, that it is 1 that is in the budget, so it's possible to build to that price. It doesn't take care if you have actually any problems that the shipyard have just fill in some figures or anything. But it usually ends up that you do need to reduce the nice requirements or some need and put that to an option list. That's why there is option list in all these procurements that is sent out. And this one is sent out in a tender for procurement. And I just made a small example for a specification, how it almost looked like every time. You have that it should make a certain speed. This is more a car example. You have that it should make a certain speed. Normally a shall requirement, but then also a should, because should is always good. It should have some crew spaces. It should have some capabilities. It should have some maneuverability, which are soft requirements normally. It should be good maneuverabilities, hard to actually verify. It should have some heat and ventilation required things that and it should fulfill all the environmental standards or the standards regarding regulations, etc., etc. And in the end, the only thing that is evaluated is the price. Even though it is put in this that you will have fancy evaluation methods, like if you can increase the speed with 1 knot, then you will get 10 more points. And so if you check the baseline, it's always the price in the end that is the tag for this one. And if you compare this one now it's a car actually that I have specified. It's more easier to see. There are 2 cars that I could imagine fulfilling this one. We have a Lada and we have a Porsche Panamera. They all fulfill these requirements. And of course, the yard have offered, perhaps not the Lada, but they have not offered the most expensive parts because it will be expensive to build. But the customer, of course, want to have this one because they want to have the best. And they are already from the beginning, you should know, they have already from the beginning cut out a lot of requirements which they wanted to have. So that's where the problems comes in, that actually how do we handle in a normal project that have a price tag about 100 or 10 million euros or something like that. How do we handle differences between buyer and seller? That is one thing we're going to talk about in small construction later on. But we mainly now have focused in the beginning. How do we make a design towards a given specification? Later on we will also discuss how do we prove that it is according to the specification without making tons of tests just to show. And also then how do we structure our design work in order to meet requirements, as well how do we structure a project in order to get into this goal. So this small craft construction consists of lectures each month, about 8 hours lecture time each time, and it's not a single subject. What we try to do is to implement all the small subjects like hydrodynamics some parts, propulsion some parts, structure some parts, general arrangement, weight calculation, stuff like that. How we try to integrate that one into one subject to actually be able to build a vessel or design the vessel. And the major thing actually is to work according to the design spiral, which I will explain to you later. I don't know how many of you are naval architects. And also to understand the equal level principle, that we can have the most fantastic propulsion in the world, but if we have a hull lines that is crap, it is no use to have it. As well, if we have the best hull lines in the world, we have spent hours and tons of money to have this fancy hull, but if the weight calculation is not done probably, that we have a total wrong displacement, or we actually have a total wrong longitudinal center of gravity, then we don't have a use for this fancy hull anyhow. As well as the weight and displacement part, if we have put a lot of effort into that one and not make any progress on propulsion, there is not any use of it anyhow. Also, there is one important thing to understand. There is no single truth. As you see, both Lada and Porsche Panamera fulfills what we were intended to do, and all the range in between as well. What we will try to do is also then, what I will try to do in this construction is to give the tools to be able to perform a decent or good enough design in all the parts. If we succeed, that we will see in the end of this semester. And also, one of the most important thing is to try to give a structure to keep a project like this. How do we handle it? How do we make the structure? How do we structure drawings and stuff like that? Because even if you have a small yard, it's not the problem with one boat. It's not the problem with two boats. When you have started to have up to 4 or 5 different type of boats that you're going to handle, then it starts to get the problem if you don't have any structure already from the beginning. So this is a little bit what we try to implement. And it wouldn't make any... I can talk about this one for students and everybody. We can then have for 4 hours and just talk about the same subject, and still it will be not performed in the same way. So what we have done then is to divide actually to different subjects, which I will show you later. But it is important to understand that small craft construction, it is not rocket science what we're dealing with. It can be if we would like to do it, but it is not in general. It needed to have some kind of the right tools, and also some curiosity, and also some positive thinking, and also some intention to solve problems. By that it is almost settled what you would like to do. What we're trying to do now is to have seminars on how things can be done and what to think of. Like, for example, design spiral, also the general arrangement, what to think of when you're making a general arrangement, work breakdown structure, which I will come back to, hydrostatics, similar small things, how to make a quick hull, for example, rules and regulation, which is needed, that everything now, even if you sell it privately, it needs to be based on some kind of rules and regulations. You're not even allowed to sell anything except you have that in your pocket already. So everything needs to be CE approved. We will also have some parts of the verification and validation and quality handling. But as I said, I can talk about it, but it won't. The only way to actually understand what the problems is when doing this one is to do it by your own. So the major part of the course is actually the homework. It is there the work shall take place. So now the class is divided into small groups. There is tasks that should be performed each month, and there is a checkpoint each month, how far we are, what information should have been provided. So last Friday there was a checkpoint when everything should have been sent in, and tomorrow we have an evaluation of how it have gone, what is sent in, what is the result of what is sent in, and stuff like that, which we will have then for an hour, and then we will continue to take lessons learned from that part, continue to make the next turn in the design spiral, because this is what it is all about in the end. It is the same thing about this weight combination with the hull, propulsion combination with the hull lines. That we need to have a setup for proportion and preliminary powering to begin with. We need to have some general lines that we believe in, at least what we know from the start. And we need also then to have some kind of general arrangement that we think can actually work, so we don't need to extend or change a huge amount of things. And the only thing what we can be assured of when we have done this one is that it will change. Because the more information we will implement in this, the more knowledge we have, the more thing we know that we have made wrong and we need to change. So for example, it was in the beginning, in normal specifications, you have that you would like to have a speed, of course. Sometimes you have that you're not allowed to have a larger length, that you have a length requirement. You also have that you have, for example, a draft that you're not allowed to go lower than, etc., etc. But there is not any requirements for displacement. Normally that is of non-interest for the customer, etc., etc. And the main focus now on the first part have been where to start when we don't have all the values. Because it is like this. Since there are no truth in the requirements at all from the beginning, and the design is complex, there are 10 different ways to start the design. You can start with the hull lines, or you can start with the propulsion, or you can start with general arrangement, and you can start whatever you like with. But the main things to understand in this part is that we can have the most advanced calculations, but we will never get one single answer. And that the design is static. Whatever we change during this process, and if it will be changed, will affect all parameters, more or less. Are there any questions so far? Are I speaking too fast? No? We also work through one of the most underestimated tools in shipbuilding, especially on the small boat side, which is the work breakdown structure. It is used in all different larger projects, as if you have normal building projects or stuff like that, in different ways. In shipbuilding it is also used, but mainly on larger ships. But it is splendid to use also in smaller vessels, even for pleasure craft. It will help a lot to use it to get the structure for drawings, everything. And this is something that can be provided. I will show you a little bit how we break it down. But it's mainly one thing that should go like a mind in all the drawings, all the thinking, etc. So for you who have not seen a work breakdown structure, it starts that we have a vessel. We break that one to separate parts like hull, accommodation, main engines, auxiliary, electrical, etc., etc. And when we have military vessels, we have combat systems and weapons and stuff like that included as well. From those major, we divide those parts into shell plating, for example, if we take the hull, shell plating, deck plating, and bulkheads. In order to know that we have all the bulkheads, type of bulkheads, we divide that one into watertight bulkheads, interior bulkheads, accommodation bulkheads, whatever. And everything is to use this as a checklist. Then we know that we have every system. If we divide everything, even the auxiliary system, like grey water, fresh water, and stuff like that, we can have it as a checklist. We can have it as a follow-up list in the project design. We can divide all the projects according to it. We can know what drawings that should be sent into classification societies if we make that once. Drawings that should be sent into maritime administrations, etc., etc. It's a splendid tool and a simple tool to use. But in real life, it doesn't look like fancy. In real life, it looks like this. How it's divided. But the principle is the same. In the small craft construction, there is a VBS structure given. It is not absolutely not obligated to follow that one, but at least there is a tool. You can invent your own. It doesn't matter as well, as long as there is in the structure. Then also one of the topic, I will cover 3 of the topics today, that we will push on is the, if I can get that one, the weight calculation, which is also one of the most underestimated tools because it's so boring to make it actually. What we will try to go into, and this doesn't matter if we have students or if we have a real project, it is extremely difficult to get a good weight calculation because there is always other things to make. It is the same thing in every project. What we will actually try to achieve is that how to set up a weight calculation, how to handle margins, because we have different margins in different stages of a project. How can we handle future growth? We will also come into that. We have presented an example of weight calculation. We will continue with that part. But the main thing is, once again, is to make their own weight calculation towards the design that we're going to make, towards the specification, what is needed. And then it is like this. This is a picture we normally use in stealth design, because it's not a matter of how you look like as long as you're invisible. But we have all the major system is not a problem, and all the small systems around it is not a problem neither, because though we know we have a hull normally, which we probably can calculate pretty accurate, but we have a huge amount of things that is below the iceberg. We only see the top of the iceberg, which we don't know. How do we handle that one? Cables, piping, all the things that we haven't included at all. That we will try to handle in this course. Here is an example of the weight calculation, how it is made in we actually use it in several now, which I've been included in. This is not 312, it's another project. Just to show how it looks like. Also to show how we use the VBS structure. Here we can see on the left side there is divided in this hull, accommodation, equipment, propulsion, auxiliary, etc., etc. Under each of those, it's actually divided separate Excel sheets with a lot of more information according to that one. We have a calculated weight normally, but as usual we don't know how much of that one is correct. And then we have a margin weight that we need to add on, and we end up with an end weight. And this is the oil recovery vessel, so it's about 830 tons. And we have a longitudinal center of gravity, etc., etc. And the principle, it doesn't matter if we have a small boat that the weight is 750 kilos, or if we have this large one. If we do it according to the same principle, it is so much easier to estimate propulsion capacity, to estimate when we go into planning vessels. For example, if we're going to estimate how märtsil will handle, what resistance we get, etc. So, for the small craft construction, the main goal is to understand ship design and vessel design and small craft design, and also make a design according to a given specification. The outcome of it all is that we will have an outline specification of the vessel, which is a small description of the vessel, including all systems, a general arrangement, some kind of power predictions, weight calculations, a hull with hull structure, and that one should be presented then in the end of it's end of May or beginning of June or something like that. Is the main thing. And the main thing with this one is also, once you have done this, if you have done this once, then you can take the same thing, copy and paste for the next vessel, whatever you will do in real life. because it's the same principle what you will use all the time. It's the same tools that you can use all the time. So it is a way to have more practice what you can have as a toolbox when you come to start building up your own yard or start working at the yard. Are there any questions about that one? No? Okay, thank you.